Welcome to another class. I'm Dr. B, your chemistry teacher, and today we are going to be discussing solutions and pH scale. Solution and pH scale. Do not forget to please share this class. And when you share this class, ask those you're sharing this class with, especially those in your groups, to subscribe. Once they click on the subscription bell, it is going to activate these classes in subsequently, and whenever these classes drop they are going to see them. And then also forget to leave your comments. Even in question form, we are going to answer them. Don't forget also to visit my Facebook page, Dr. B Chemistry Classes or Science Classes, and share as well. Ask them to follow while you do a like and also comment, as the case may be. Fine. We are going to be looking at solutions and pH scale. Solutions and pH scale. But of what importance is this topic we are about to do justice to this very day? It's important because there are a lot of things we do in life that are actually detrimental to our health, and they are actually harmful to our lives as a whole, that we do not understand where most of these solutions, especially the ones that we consume, belongs to as far as the pH scale is concerned. So today, at the end of this class, you will not have only learned chemistry, but you will have also understand most of those life challenging solutions that you are actually consuming that are of issue, all right, to your own health. Now, what is pH scale all about? pH simply describe hydrogen ion concentration. That is the definition. All right, it just simply discusses hydrogen ion concentration of a particular solution, of a particular substance, the hydrogen ion concentration of a particular substance. And that is what the pH scale try to define. In every solution, we try to look at the hydrogen ion concentration. Now, if you look at the solutions or the solutions you take or the substances you take, is either those substances are acidic or those substances are basic or alkaline. Yes. So whatever substance that we consume in our lives is either acidic or it is what alkaline in nature. And being acidic or alkaline is defined by the presence of the hydrogen ion concentration in that particular substance or solution that you consume or you used. And now, the pH scale allow you to be able to define whether that particular substance you are consuming is acidic or it is basic or alkaline, as the case may be. And if it is acidic or it is basic, whether it is strongly basic or strongly acidic, or weakly basic or weakly acidic. So if it is strongly acidic or so, it has its own detrimental effects. If it is a weak acid has also its own detrimental effects. The same thing if it's a weak base or if it is a strong base. Now, we mentioned something. We said it is either basic or alkaline. But what do we mean? Because we will have only just say it is a base or it's an alkaline. Okay. Now, if you take a look at bases, okay, customarily bases do not dissolve in water. That is how they are made. Bases are not soluble, they are quite insoluble. But bases that are now soluble are always described as alkali. And alkaline solutions, of course, are always being defined as soluble bases. In short, that is your definition. Alkaline solutions are always soluble bases, okay? And if they are soluble bases, it therefore means that all alkaline solutions are bases, but not all bases are alkaline. We're going to discuss that in our subsequent class. We'll look at how we can be able to differentiate between a base and an alkaline. But just know today that not all bases are alkaline, but all alkaline solutions are bases. This is because bases that the bases that can dissolve in water, and there are some bases that cannot dissolve in water. So those ones that can dissolve in water, like sodium hydroxide for example, potassium hydroxide for example, are all alkaline solutions. So we describe them as soluble bases. Now, whether they are soluble bases or they are bases, they have their positions in the pH scale. And today we are going to look at the pH scale and see what solutions belong to what pH and why it is a bit detrimental, it is a bit detrimental to our health, or why it is quite okay to our health. Now we take a very good look. What interests me here basically is the beer. A lot of us take beer and then we do not even understand the fact that beer is acidic. Now, this is because the pH scale is divided into two. Let me put it in that way, in two ways. And in those two ways, is one of the ways which is towards your left is the acidic, and the ones that is towards your right is the alkaline. The pH scale is divided from is written from 0 down to 14, and in some books it is from 1 to 14. It has a margin where you have the neutral point, which is 7. So for every solution that is neutral has a pH of 7. And an example of that is the distilled water. Distilled water is not acidic and also not alkaline. That means that if you take a litmus paper, whether blue or red litmus paper, and dip it in a distilled water, it will be unchanged. Remember that if you dip a red litmus paper in a solution and the litmus paper turn into blue, it means that that solution is alkaline or basic. If you dip a litmus paper that is blue in a solution and it turns red, that means that that solution is acidic. But if you dip a litmus paper in a distilled water, that particular litmus paper will remain unchanged. That means that that distilled water contains no acid or base, so it is neutral. So the pH of distilled water is what is neutral, is 7. Now that is understandable. Now if you move from your left, going to your far right in a row, you are moving towards high alkalinity, high basicity. So from 8 moving down to 14, in a pH scale, you are moving towards higher what alkalinity or basicity. Now, if you are moving from your right down to your left, after 7, you are approaching 0. That means you are moving towards high acidity. So the pH scale has acidity that is the left and the alkalinity right in between the neutral, which is 7. So all neutral solutions are having a pH of 7. Now when you take a look at beer, beer has a pH of 4. In fact, you can see where the beer is, about 4 point something. But who had ever known that beer contains acid? And if beer has a pH at around 4, that means that it is having what? High acidity already with it. And if beer has high acidity with it, what does that mean? That means that if you take beer, you trigger what? You trigger acid, increase acid content in your stomach. But let's take a look at another. Look at where we have gastric juice or stomach acid. Stomach acid is 1. Yes, the stomach acid has a pH of 1. And this is high acidity. So if the stomach acid or gastric juice has a pH of 1, that means that there is already an existence of high acidity in the stomach. Of course, I'm not surprised. It's the reason why we are told that the stomach contains hydrochloric acid. So when you starve yourself, the hydrochloric acid is going to be released. It used to be released spontaneously. So once it is released and find no food for it to do the normal churning of that food, it rather now lie on the walls of your intestine and it start doing what? It start burning the walls of your intestine. Perhaps the reason why you talk about gastric ulcer. So it is very important to always eat and regularly. Now let's come to this theory. If the gastric juice is having a pH of 1, which is high acidity already inside your stomach, you are born with that to help in the churning of food, all right? And also help in the stopping of the action of xylem that comes from your mouth. Now, if this acid is high already and you drink beer, which has an acid of about 4 in an empty stomach, what do you think that will happen? It's why I said this study will help us a long way. A lot of us sometimes could just drive from somewhere when you even know that you are hungry already. Okay, and while you are feeling the signs of hunger, it is even because the concentrated acid already, which is the gastric acid in your stomach, is already acting on the walls of your intestine. And sometimes we drive our cars into a particular beer parlor where we sit down and start taking beer without even eating food. What effect do you think you've caused for yourself? Now, what you've done is simple. You have decided to take beer with a pH of about 4, being acidic, adding it to what? The gastric acid with a pH of 1 already, increasing the acidity content of your what? Intestine. Are you doing yourself any good at that time? No. You are killing yourself instead. So we need to know this. When you now know that the acid content of beer is about 4, and then your original acid content in your stomach is 1, high concentrations already, you will know how you can be able to manage your life instead of moving an empty stomach with acid already inside on a pH of 1, taking beer with acid again on a pH of 4 and an empty stomach. At the end of the day, you will not have been doing yourself any good. So today you have learned that beer contains an acid, has an acid of about 4, all right, in the pH scale. So it is high. And then the gastric juice or the stomach acid itself is at the pH of 1. Both are high. You must make sure you eat. Very important. To drink beer, you must make sure you eat as well. And to drink beer, you must consume later. All right, now we have that. We are also told that coffee has a pH of 5. A lot of us like taking coffee. And a pH of 5 is showing acidity already, even though it is more like weak acid. But it is not also too good to be taken, especially at empty stomach, or to be taken regularly. Now you can also see that we have acid battery has a pH of 0. That means very high. And that is why you must avoid pouring acid batteries around your hands or around even metals. For those of you who have cars and use acid battery, use batteries, car batteries and all those stuff. So they contain acids that are at the pH of 0 already quite high. So you must avoid managing them. And then you also have orange juice here. Orange juice and vinegar are having the same acid content. Well, how would you have believed that vinegar has acid? A lot of people take vinegar. Some of these herbal medicine you take, they tell you have vinegar. You must be very careful with most of these herbal drugs you take, especially these ones they pass on to sell, because the amount of vinegar that you may not know. And then it triggers acidity content in your body because it contains an acid which is almost at 4, about 3.5, and that is the same thing with orange juice. No wonder you are also not advised to take orange when you are with empty stomach or when you are hungry, because it triggers the acid content of the gastric juice. Alright, and then when you take oranges, and then when you are having constipation, you take orange and it goes down, what do you think has happened? It is the effect of the acidity from that particular orange that causes for the breakdown of the food that you took that granted that constipation. And now we are also told here that pure rainwater has a mild acid content of about 5.6, and then you have milk which also has an acid content quite closer to 6, though a weak acid. You now have also seawater that is basic, is alkaline in nature, but weak alkalinity. Remember that just like acids are very corrosive, bases are also corrosive. Strong bases are highly corrosive. So if you have seawater having a pH of 8, it means that it has a weak it's a weak base. It has weak amount of alkalinity in it. But what happened with let's look at something like your bleach, household bleach, the sodium chloride or hypochlorite as the case may be. it is having a pH of about 12.5, and that means it is highly alkaline. So it's corrosive, and that is why your household bleach, if you use it on your empty hands, you can possibly have your hands being eaten off. That means that your skin being eaten off because it is highly what? Salty. It's highly basic, highly alkaline. Now the same thing comes to what you call milk of magnesia. It has a pH of 10.11, all right? And what is milk of magnesia? Milk of magnesia is basically used in drugs. It is always used it used to cope acidity in your stomach, sometimes like antacid. So you use the milk of magnesia, which is magnesium hydroxide, preparing those antacid. And the antacid is highly what? Basic or alkaline in nature. It is the reason why when you have issues with gas or acid in your stomach that give rise to gas, you take antacid, which contains milk of magnesia, to do what? Since it is highly basic, it reacts with the acid. What will it give you? Acid reacts with what? With a base to give you salt and water. And in that way, it is going to drop the constipation or drop that particular high acidity, which is giving you that level of stomatal upset at the end of the day. So you can see that even blood has a pH of about 7.8, and that means that blood is a little bit alkaline in nature. And lemon juice is here as well. Lemon juice is here. Tomato is also having the same pH like orange juice, and vinegar has the same as beer. And look at milk with a pH of a little bit acidity away from what? The neutral. And all these are here, and all these are treated for us to understand the enormity of some of those particular activities that we carry out, using either directly or indirectly some solutions, consuming directly or indirectly some solutions, their effects in our body. I'm sure that with this class today on solutions and pH scale, you have been able to learn something so important about the nature of the various solutions that we consume directly or indirectly. Until next time, I remain your Dr. B. Do not forget to like, do not forget to share, do not forget also to subscribe. When you share these classes, please ask them to also subscribe to be part of these classes next time. They will pop up at once they are dropped in the YouTube